For this problem, we are tasked to draw the shear and moment diagrams and determine the maximum normal stress due to bending. So we have our rectangular beam here with 80 by 250 mm dimension, and it is simply supported at B and D. We have a pin here and a roller, and two concentrated loads applied, 20 kilonewton and 40 kilonewton. So to start with, let's try to draw the free body diagram of the beam. So replace B with this one, reaction at B, and replace D with reaction at D. We have no horizontal loading here, as you can see. So the horizontal loading at B is 0, so it's negligible. Then uh, we try to consider the entire beam as a whole. So we have to summation of all forces along X, along Y. We have two unknowns, reaction at B and reaction at T, RB and RD. But then we can have another equation. Summation of all moments must be 0 for this equation to be stable. So if we sum all the moments at point D, then we will get RB, and RB is equals to 46 kilonewton. So summation of all forces along Y, then you will get RD is equals to 14 kilonewtons. It's true that our assumption that the direction of B is upwards, the same with D, because it will balance the applied load 20 and 40 kilonewtons. So to start with our shear and bending moment diagrams, we first determine the internal forces just to the right of the 20 kilonewton at A. Then consider the stub of beam to the left of section I as a free body, and assuming that the uh, V1 and M1 to be positive according to the standard convention. So if our beam is to the right, our beam is to the left, then our positive shear is going down and our moment will be in this direction here. This is our convention, positive going down and the moment is going here if our beam is to the left. So summation of all forces at here is equals to negative 20 since it's down minus V1 is equals to 0. And don't be confused because when we sum all forces, let's go back to the general convention, general sign convention, that all forces going down is negative and all forces going up is positive. So this is negative 20 minus V1 is equal to 0. Therefore, your V1 is negative 20. So our assumption that V1 is going down and it's negative, therefore our V is going up. Why? Obviously, because at this point, if 20 kilonewton is applied downwards, then this shear here, V1, should be upwards to resist the force 20 kilonewton. Okay, let's sum the moments. And at this portion, since um, the value of X is just right after the application of 20 kilonewtons, so the value is 0. So that is why this here. Therefore, at point right after the application of point of 20, the moment is 0. But we have the shear, negative 20 down. Then, right before the application, right before the reaction, B at B. So we will cut it and let's see how it goes. Summation of all forces, V2 is negative 20, the same. So from here up to the point here, the shear is negative 20. And this is to resist the applied load here. But we have already a moment. Summation of all forces, summation of all moments at just right before B here, M2, solve for M2. Our convention is that M2 is padulong ana, di ba? And our V2 is going down. But let's see what is the correct answer. So summation of forces, general convention, okay, is going up, positive, going down, negative. So negative 20, then since it is going down, you have negative 20, and the answer is negative 20 kilonewton. So therefore, our convention that V2 is going down is it should be negative 20. So pasabot, ang atong V2 is pasaka. Okay, and RM moment at this point is summation of moments here is equal to 0. So let's equate. We have 20 multiplied by 2.5 here and M2. So you get M2 as negative 50. So our assumption that the moment is inani ang kuan dili di ay kay negative man siya. Pasabot ang atong moment is pana. Atong resisting moment. Ano man, kani siya nga load muana siya, di ba? Makahatag siya moment nga kaning 20 makatag di siya moment nga padulong dito. So para i-resist na siya, dapat na ay moment nga paana. Okay? And this is atong kaya nga atong assumption paana man ato ang positive na moment, di ba? So negative man atong answer kung wabot ang point nga positive gyapon atong answer dito pasabot sakto na atong assumption nga ang positive padong dito, but since the result is negative, so dapat mobalik ta sa tuang direction. Instead of paana siya, kani ang sakto nga direction sa moment at point just before the B. Okay, let's move right after B. Unsay nahitabo? So kung dili tag-apply og reaction at point dinhi right after, unsay mahitabo? Okay, let's continue with the right after sa point ato application sa point P. So ikat na to siya dire, mo ni ang mahitabo niya. Okay, you following? So we have shear and moment. Since our convention is that kung ang beam nato is to the left, then our assumption that the shear, the positive shear is going down, and our moment is counterclockwise. Okay, let's see kung sakto nga tong convention, sakto nga to ang assumption, I mean. So the shear and bending moments at section 3, 4, 5, and 6 are determined in a similar way sa pagbuhat nato sa section 1 and section 2. So, summation of all forces along along Y, I mean, then summation of moments. At point 3, our shear is positive 26. So, sakto siya nga going down, and our moment is negative 50. Therefore, instead of inani, ang atong moment is clockwise. Okay? Muna ang sakto nga moment. At point 4, here, our shear is 26, going down, correct? And our moment is positive 23. 28, I mean. So, insakto na ni siya nga paana na. As is na ang iyang convention. And therefore, hangtod nga maabot ka sa imuhang point D, which is at point 6, 0 na ang moment, and your shear is equal to negative 14. So, kani siya is equal to negative 6. Pareho, equivalent na niyang value ani, and at point 4 here before. So, For several and later sections, the results may be more easily obtained by considering a free body of the portion of the beam to the right of the section. For example, for the portions of the beam to the right of the section 4, to the right ani niya, kani, so muna itong giputol dire. So, para makita nimo nga kung unsa ang iyang reaction at makuha nimo ang V prime 4 of M prime 4. So, ang V4 is C28 at 26 and M4 is positive. So, when you consider this one, tanawa ha, ang atong sign convention is going up for shear and clockwise for moment. And that is our assumption if the beam considered is to the right. Diba mo itong sign convention positive? And that is correct when you check to this, when you consider this portion. Diba kani nga portion compared to this one. Aha, may masayon tan-aon or masayon isolve kani nga portion or kani. Diba kani siya? Kay you will only consider kani isa. Whereas if you have this one, you have to consider the reaction at B and the point concentrated load at point A. So, ito siya kung i-discuss earlier nga, you have to be wise in selecting the cross-section kung asa nga part imong pilion sa beam. Anyway, the value of M4 and M prime 4 is equivalent and the value of V4 and V prime 4 is also the same. Okay? So, we can now draw, diba? So, from point A to point B, the answer is, you have negative 20 nga shear. So, negative down 20. Negative 20. And then, at point B, there's an reaction of 46 kilonewton. So, negative 20 here. 26 there. So, nga ana kay 26 kilonewton din he. So, all throughout, 26 kilonewton. And then, there is a applied load 40. So, from 26, mo down ka padulong diri og negative 14. Kay kani nga magnitude is 40. Kani nga magnitude gikan diri padulong diri is 46. So, from point C up to point D, you have negative 14 nga shear. Okay? So, for the moment at point is 0. But then, the moment at right after here it's, the moment here is, ila to? At point 2, the moment is negative 50 at point 2. So, the moment here is negative 50. And then, at point C, ila ang moment sa point C? You have point C, you have the moment M5. And M5 is positive 28. So, 28 here. And back to 0 sa support D. Why? Because it's a roller. So, walay moment reaction din na. Okay. So, nanatay shear force diagram, nanatay bending moment diagram. Then, let's find the maximum stress experienced by the beam due to bending. So, let's consider the moment. So, let's first solve the section modulus of the beam. Then, we have 80 mm or 0.80 meter and 250 mm. So, the equation to be used, since it is a regular rectangle beam, S is equals to 1 over 6 BH squared. you get the section modulus. And then substituting the equation of maximum stress is equals to M over S. And the maximum value for moment here is negative 50, but it's an absolute value, then you'll get 50 times 10 raised to the power of 3, and times M over the calculated value of suction modulus, you get this 60 MPa maximum stress experienced by the beam. Okay? So that is at this point, at point B. This is where the maximum stress fell. Diri nga point sa beam, feel niya ang maximum stress. Any questions? Okay, so let's proceed to your assignment. This is your assignment number 1. The structure shown consists of rolled, so this is a dimension of the beam, and 2 short members welded together to the beam. Draw the shear and bending moment diagrams of the beam for the given loading. So you have a distributed load 45 kilonewton per meter for 2.5 meters. Then at point E, you have 45 kilonewton. Okay, so number 2, draw the shear and bending moment diagrams for the beams and loading shown. So you have a simply supported beam, point A, and an overhang at point E, and a pin at a roller at point B. So you have point A to point B 1.6, point B to point C 2.4, point C to point D 3 meters, and point D to point E is 2.4 meters. And this is 90 kilonewton. Concentrated load applied at B. Concentrated load applied at C is 54 kilonewton, and a uniform distributed loading of 22 kilonewton per meter. So your assignment will be given, you will have 1 week to answer this assignment. It will be due next week and be uploaded at your LMS.